And yet we come back for another segment. We are looking at question number 3. What question number 3 is a little bit longer, so we're also going to divide it into 3 segments as well. So we're going to be dealing with sets, we're going to be dealing with logs, we're going to be dealing with exponents. We're also going to be looking at complex numbers in question number 3. All right, let's start with 3.1.1. We are given 3.1.1. We are given 2 to the exponent of minus 2, multiply that by 5 to the exponent of 0. All of this is divided by 3 to the exponent of minus 1. They say we must simplify without the use of a calculator, but hey, yeah. Okay, so what do we have? In the first part, we're going to have 2 to the exponent of minus 2 multiplied by anything to the exponent of 0, just put a 1 there. All of this is divided by 3 to the exponent of minus 1. So what are we going to have here? 2 to the exponent of negative 2. This is going to simplify to be 2 to the exponent of negative 2 divided by 3 to the exponent of negative 1. You can simplify this, no? We can simplify this, but you can just press your calculator. I know what they said, yes. But just put in your calculator there, you're going to end up with 3 divided by 4. But if you want to simplify it, let me just change the color there. But if you want to simplify it, in your numerator, you're going to have 1 divided by 2 to the exponent of 2 divided by, in your denominator, you're going to have 1 divided by 3, which is going to be 1 divided by 4 multiplied by, when you change the division line into the multiplication, it means these ones that are going to invert. You're going to have 3 over 1. And then this is going to simplify to be 3 divided by 4. But yeah, okay. So that is our 3.1.1. Now, 3.1.2, we have open bracket 2 multiplied by the cube root of 8a to the exponent of 2, all of that to the exponent of 3 over 2. Okay, now this one is going to be a little bit tedious, but it's the easy way to go. All right, so what you're going to have, let me just open those brackets. I'm going to have 2 multiplied by, you can separate what you have inside the cube root. You can write it as having the cube root of 8 multiply this by the cube root of a squared. All of this to the exponent of 3 over 2. And then this is going to give us 2 multiplied by the cube root of 8 is 2 multiplied by, if you change this and write it in exponential form, it's going to be a to the exponent of what? 2 divided by 3. All of this is to the exponent of 3 over 2. Now look what's going to happen. The exponent outside is going to multiply everybody inside the brackets. But before we do that, let's simplify this one. We know that on 2 we have an exponent of 1, we have an exponent of 1, multiplying powers of the same base, you add the exponent. So this is the same as 2 to the exponent of 2. Multiply this by a to the exponent of 3. No, it's not 3, it's 2 divided by 3. 2 divided by 3. All of this to the exponent of 3 divided by 2. Now you can multiply. Now let me use this side. Now you can multiply. Removing the brackets, you're going to have 2 to the exponent of 2 multiplied by, this 3 over 2 is going to multiply this, so it's going to be 3 divided by 2. Multiply this by a to the exponent of 2 over 3 multiplied by 3 over 2. Aha. Then 2 and 2 are going to divide. You'll be left with 2 to the exponent of 3 times 2 and 2 they divide, 3 and 3 they divide. You'll be left with a 2 to the exponent of 3. It is 8a. There is your final answer there. That is your final answer. So what you are supposed to do is to apply the rules of sets by simply separating what you have inside here. This one to the cube root of 8, and then this one to the cube root of 8 squared. When you simplify this, it gives you this. When you simplify this, write it in exponential form. This is what you get. Multiplying powers of the same base, you add the exponents. This is what you have. And then what you're going to do now, you're going to take the exponent that is outside the bracket, this one here. This one is going to multiply this one, and this is what you end up with here. You end up with this 3 over 2 multiplying the exponent of 2. Same applies to this part, 3 over 2 multiplying 2 over 3. And then here 2 and 2, they divide, you're left with 3. 2 to the exponent of 3 will give us 8, and then these ones, they're going to give us an exponent of 1. Basically, you're left with 1 there, and then your final answer becomes 8a. So I'm going to clean up this whole thing so that we can work with logs. Let's look at logs. Okay, so what do we have on logs? We are given the log of 8 base 2. Put that inside your bracket. Multiply that by the log of 32 base 3. Put that inside your bracket. Multiply this by the log of 243 base 16. Multiply this by 1 divided by 5. Not a problem. Let us apply or remind ourselves about something about logs. Is that if you have the log of a b, this is the same as having the log of a divided by the log of b. No? So we're going to apply this one here. So the log of 8 base 2, it can be written as the log of 8 divided by the log of 2. Put that inside your bracket. Multiplied by, same applies here, I'm going to have what? The log of 32 divided by the log of 3. I'm going to do the same thing here. The log of 243 divided by the log of 16. Don't forget to write that 1 divided by 5. Okay, now you're going to write everything in exponential form. What you did, that is what you're going to do. So log of 8 is 2 to the exponent of 3. You divide this by the log of 2. Put that inside your bracket, very much important. And then 32 as well is going to be what? 32 is going to be the log of 2 to the exponent of 5. Yes, to the exponent of 5, all divided by the log of 3. And then lastly, 243 in exponential form, it's 3 to the exponent of 5. So this is going to be the log of 3 to the exponent of 5. What about 16? 16 is the same as 2 to the exponent of 4. All of this multiplied by 1 over 5. Again, let us remind ourselves about another rule. When you have the log of a to the exponent of n, this can be written as n multiplied by the log of a. Remember that, né? So that's what I'm going to do next. So what I'm going to do is that I'm going to take all of my exponents here and put them here where n is, né? So this one basically is going to be 3 into the log of 2. You divide this by the log of 2. Multiply by, here I'm going to have 5 into the log of 2. You divide that by the log of 3. Multiply that by, I'm going to have 5 into the log of 3, all divided by 4 into the log of 2, all of this multiplied by 1 over 5. Look what's going to happen. This log 2 and log 2 they're going to divide. Log 2 and log 2 they're going to divide. Log 3 and log 3 they are going to divide. So what will you be left with? This side you will be left with 3 multiplied by this part here, you'll be left with 5 multiplied by this part, you'll be left with 5 over 4, 5 divided by 4 multiplied by, and then you have 1 over 5. Okay, what can happen also here is that this 5 and this 5 they can divide, and then if 5 and 5 divide, 5 multiplied by 3, I'm left with 15. 5 multiplied by 3, these two here, they're going to give me 15 multiplied by 1. So I'll be left with 15 divided by, don't forget that guy there, it's 4. Yes. So the final answer for this one here, it is the same as 15 divided by 4. Yes. We just applied two simple rules of logarithms, this one here and this one here. They are the ones that helped us to simplify this solution here. So that is 3.1.3. Let's move on. 3.2, solve for x. We have to solve for x. Okay, so let's see, what do we have here? So we are given the log of x plus 1 minus the log of x minus 1. All of this, it is equal to 0. First and first, this one doesn't belong here, so I'm going to transpose him to the other side of the equation. So this side, I'm going to be left with x plus 1 minus the log of x. This is equal to 1. It's going to change the sign from negative and then becomes positive. Okay. Let us remind ourselves something about logs in this case. We know that if you have the log of a minus the log of b, this is the same as having the log of a divided by the log of b. Yeah? Let me put a box around this. So that's what I'm going to do here. This is the rule I'm going to apply here. Okay, so it means that this can be written as the log of x plus 1 divided by x. All of this, it is equals to 1. Now remember that there are two ways we can simplify this. The first one is that we know that the log of 10 base 10, it is equals to 1. That's the one thing we know. And then that's one of the rules that we can apply. Another thing that we can use is that we can change our equations from log form into exponential form, which is also another way of doing it. For example, if you are given the log of a, b, and then this is equal to c, this is in the log form. If you want to write this in exponential form, this is your base, your b, to the exponent of c, this is equal to a. So basically it's like you're crossing like this. This one, you cross it, it becomes an exponent, and then this one is like you're multiplying it by 1. It's like you're multiplying it by 1, and then it becomes a like this. So we can exchange these and write it in this form, change it from log form to exponential form, or I can simply just use this. I like the first one. So I'm just going to change 1 and say that 1 can be written as log 10 base 10. So what I'm going to have here, I'm going to have the log of x plus 1 divided by x. This is equals to the log of 10. Now, what do I have? Remember, in exponents, when the bases are the same, you equate the exponents. So same applies here. The bases are the same. I have a base of 10 here. I have a base of 10 here. They do not cancel. They are the same. So if I have this one, and this one, they are the same. So that means I can equate what I have inside the bracket. So what I have inside here, I have x plus 1 divided by x. this is equal to 10. I can equate them. I'm looking for x, so I'm going to multiply both sides by x, and then x plus 1, it is going to give me 10x. You transpose, you have x minus 10x, like that, is equals to -1. When you take this to this side, becomes negative. When you take 1 to this side, it's also becoming negative. Then I'm going to have negative 9x equals to -1. Then you divide both sides by negative 9, yes. Then it's going to make the value of x to be 1 divided by 9. The key things that you needed to remember here is this rule, and one of the two, you can choose one of the two, still work out the same way. Here, if you were to change it into exponential form, let me put it here. If you were to change this and write it in exponential form, remember the base here is 10. So we're going to say 10 to the exponent of 1. So it was going to be 10 to the exponent of 1. It is equals to this whole thing multiplied by, let's say you have 1 there. So you're going to have x plus 1 divided by x, which is exactly what we have down there. So this part is the exponential form of this one. So this is the exponential form and also the log form. So yes, you can choose one of the two methods. In either way, we arrive at the same answer. The answer it is 1 divided by 9. Okay, let's look at 3.2.2. I'm going to erase everything here so that I can get some space. 3.2.2, it's exponential equation. We have 3 to the exponent of 2x plus 3 to the exponent of 2x plus 1. This is equal to 36. Okay, what are we expected to do here? We're expected to find the value of x. Remember guys, the first rule of exponents that said multiplying powers of the same base, you add the exponents. When you have a to the exponent of x multiplied by a to the exponent of y, this is the same as a to the exponent of x plus y. Guys, the rule is not it is reversible. It goes to the left at the same time it goes to the right. If you are given something like this, then you can express it like this, and then if it's given in this form, then you can just reverse the rule and take it back into this format. So that's what I'm going to do here. All right, so let's see. So I have 3 to the exponent of 2x plus this is going to be 3 to the exponent of 2x multiplied by 3 to the exponent of 1. All of this is equals to 36, giving me a common factor of 3 to the exponent of 2x. When you take that out, you'll be left with 1 plus 3. All of this, it is going to give us 36. So 3 to the exponent of 2x into 4, this is equals to 36. You divide both sides by 4. Also this side you divide by 4. 4 and 4, they divide. I'm left with 3 to the exponent of 2x. And then just use your calculator. 36 divided by 4, it's going to give us 9. You can write 9 in exponential form. So 3 to the exponent of 2x is the same as 3 to the exponent of 2. Bases are the same. You equate the exponents. So 2x, it is equal to 2. You divide both sides by 2. And then you'll find that the value of x, it is equals to 1. Yes, that's unique. The value of x, it is equals to 1. So that is 3.2. It was exponents and logs and also sets. Now let's look at complex numbers. Question number 3. They say, given the complex number z equals to the root of 2 into cos 60 plus I into sin 60. This one is our polar form. This one is our polar form or trigonometric form, whichever way you want to call it. The question says express z in the form of a plus bi. A plus bi is our rectangular form. So 3.3.1 z, which is given in this form, we're going to change it. So we're given the square root of 2 into the cosine of 60 degrees plus I, multiply that by the sine of 60 degrees. Z is going to be, this is going to be root 2 into, then you press your calculator here, guys. When you press your calculator, the cosine of 60 degrees is going to give us 1 over 2 plus I multiplied by the sine of 60 degrees is going to give us the square root of 3 over 2. And then you remove the brackets. The square root of 2 multiplied by half is going to give us, sorry about that, yeah. It's going to give us the square root of 2 divided by 2 plus the square root of 2 multiplied by the square root of 3 over 2 is going to give us the square root of 6 divided by 2. Don't forget to write I. So this is your rectangular form, says A plus BI. That's how they wanted the question. 3.3.2, it says write down the conjugate. Remember, guys, the conjugate, you change the sign of the complex part. If you are given z equals to a plus bi, when you write down the conjugate of this one here, when you write down the conjugate, you change the sign of the complex part. So your conjugate is going to be a minus bi. So this part here is the one that is complex. You change the sign of that part. So this is our rectangular form, z, which is given by the square root of 2 divided by 2 plus I multiplied by the square root of 6 over 2. It's still the same thing, guys. So which part is complex? This one here is the one that is complex. So this one here is positive. So when we write it as a conjugate, it's going to be the square root of 2 over 2. It remains the same. That one doesn't change. But then what changes is this one. It becomes minus root 6 over 2i. Yes, and this becomes our final answer over there. And then 3.3.3.3. Okay, they say represent z on an Argand diagram on the complex answer sheet. So the complex the answer sheet was provided to you, but what I'm going to do here is that I'm going to draw my own Cartesian plane here, where I'm going to have the real parts and the imaginary parts. The real and the imaginary, not parts, exist. Thank you. Yeah, not parts but exist. Okay, let's look at our z. We represent the original. Ne? We're going to represent the original on this one. Both of them are positive, guys, and both of them are positive. So yes, square root of 2 over 2 is real. You can just put it somewhere here. It's gonna be the square root of 2 over 2. You can write this in decimal. In decimal it's 0.71. Let me just put it here, 0.71. And then your real part is a little bit greater than this. It's going to be somewhere up there. Your imaginary, I mean, your imaginary is going to be the square root of 6 divided by 2 up there. Even this one you can write it in decimal. It's still not a problem. And then where the two meet, it's somewhere up there. You're just going to draw a straight line. When you use the grid that is provided to you, it's going to be as perfect as possible. So this is how it's going to look like. Your imaginary, and then you have the real, your imaginary and the real exist, and then you just insert your values, and then you draw a straight line on the grid provided is going to be as perfect as possible. Yes. So this brings us to the end of question 3. We'll be looking at question number 4, where we'll be talking graphs and functions. See you guys in the next segment. Bye bye.